All right, so this type of problem, there's going to be a table right here. Again, advantage of this for AP Central's point of view is good luck Googling how to deal with a table, right? If not, there are not going to be a lot of right answers to this. So the odds are this is a pretty good question to ask. It's a little narrow. In other words, they're going to want to ask you about every chapter we did, and it's really not every chapter we did stuff here, but it could be so. When you see a table, the first thing you should be thinking of, hopefully, when you're dealing with an AP test, is you're going to deal with one of two things. You're going to say Riemann sums. You're going to Riemann trapezoid, midpoint, Riemann sums, some sort of Riemann sum. Because I don't have actual equation, and I have to do calculus, I'm going to have to estimate the value of this thing in some way or another. So the odds are you should start feeling, well, probably going to have to deal with a Riemann sum. So anything you should be looking at is if they give me 2 points, they want to know the average slope between those 2 points. In other words, they want to know, let's say they wanted to know at 6, the rate at which whatever is happening here. Well, then you would simply go, well, I have 2 points I know, so I could estimate that by doing 21 minus 13 over 7 minus 2. In other words, use your formula, slope formula. In this case, you would get 4 whatevers divided by whatevers would be the way to find the derivative at 6, or estimate the derivative at 6. Great. So, I just did problem number 1. Okay, so let's do problem 2a. What does problem 2a says? Use a data table to approximate the rate to 100 entries per hour in which entries were being deposited at time equals 6. Show the computations that led to your answer. Oh, well, I wonder how I did do that. Well, time equals 6 is not on my chart, but that's okay because I want to estimate the rate between 5 and 7. So the rate between 5 and 7, the best way to estimate them if you've only got data points is to take the slope. The average slope might even be right? So you take the average slope it rises 21 minus 13, or it goes up 8. It runs 7 minus 2. Oh, I did the math wrong. 7 minus 2 is not 2. 7 minus 5, though. Aha. 7 minus 5 is 2, though. 7 minus 2, so this is 8 over 4, or 8 over 2, which is going to be 400 entries per hour, it looks like. Okay? So 400 entries per hour. I know you can't read that, but that's because I wrote it badly. All right, good so far? Okay, so that's the first type of problem I said watch out for. That's it right there. In a nutshell, that is the type of problem they like to ask. Okay? Do you know what we've been talking about all along? The average slope would be the derivative someplace, right? And it's the best way to approximate the derivative if you do not have an equation for it, right? A model of any sort. Okay, B. Let's see what B says. B says trapezoid sum. I'm right on the money. Look at this. Use trapezoid sum to estimate, to approximate this. Okay, so there's 2 things that just pop in your head the moment you saw this. One, a trapezoid sum. That's kind of weird, but that does the integral part, right? Second thing, what is this 1/8, 0 to 8? What is this stuff? Oh, it's an average. So it says using correct units, explain the meaning of this. The meaning of this is it is the average. If ET is measured in hundreds per, it's the average rate. It's the average rate per of hundreds of entries per hour. Should be N. Is the average rate at which people are putting in ballots. Right? Okay. Oh, no. It's the average. Sorry, my bad. It says here it's hundreds of entries. There's no rate on here at all, so I'm completely wrong. So let me back up. It's the average number of, it's the average. So E is just the, how many are in the bucket, right? So this is the average ballots or entries in the box. Okay, it's the average number of entries in the box for the first 8 hours. For time equals 0 to 8. Okay. All right, how do I find it? Trapezoid rule. I'm going to sketch it over here because I need a little bit of room. 0, 0 is a point. Nice. I've got 2, 4. I've got 5, 13. Uh-oh. I got 7, 21. And I've got 8, 23. Okay? So triangles, rectangles, triangles, rectangles, triangles, rectangles, and no rectangle on this one because it's bottom of 0, right? So that would be 1/2 2 times 4 plus 1/2 9 times 3 plus 3 times 4, right? For this area here, it'd be 3 times 4. This triangle on top would be 1/2. The height's 9 because it's 13 to 4, right? Okay, next one would be 1/2 2 times 8 plus 13 times 2 plus, and then at the top I'm going to have 1/2 2 times the base is 1, 7, 8, and then plus 21 times 1. All right. Getting the calculator. I got 4 plus 27 divided by 2 plus 12 plus 8 plus 26 plus 1 plus 21. And I get 85. Oops, my pen. I get 85.5. And then remember, we got to divide by 8. So I'm going to divide that by 8, and I get 10.688. And that would be correct. You just the average hundreds of entries. So that's how many hundreds of entries I have at the moment. Okay? So that'd be part B. And then the average, obviously, it's the average number of entries in the box for the first 8 hours. Okay, at C, at 8 p.m., the volunteers begin to process the entries. They process the entries at a rate that can be modeled in the following way, where hundreds of entries per hour from 8 to 12, according to the model, how many entries can you process, but can be processed by midnight? Okay, so they say 8 p.m. processed in this rate, so I'm just going to slap it into my if this is the rate, how do I turn it into a number of entries? I integrate, right? So I'm going to integrate t cubed minus 30t squared plus 298t minus 976. And this is a golden opportunity to use your skills with the calculator that you've thus far developed. DT. So I'm going to try to figure out, they started at 8, right? So I'm going to start my process at 8. And so then I get out my calculator. I'm going to hit Option, Calculator, Integrate. I'm going to type all this in. X up caret 3 minus 30 x up caret 2 plus 298x minus 976. Can't read it. 976. I hope I'm reading this right. Then you put in your commas, right? Or if you've got your TI for people that don't know how to do things, you just put them where they go, right? It's even better. 16, so I got 1,600 entries. So I got 1,600 entries, right? That's how many they processed. Oops, 1,600 entries. And I'm feeling excited about it, except that's not the question. It's how many entries have not yet been done. Oh, crud. Well, at 8 hours, we know there's 2,300 in there, right? So I'm just going to go 2,300 minus 1,600, and I'm going to get 700 entries still left to be done. Smiley face. All right, according to the model from Part C, at what time were the entries being processed most quickly? Justify your answer. How do I find the maximum rate at which they're being processed? Oh, hey. So I want to find the maximum rate, so I got to take the derivative of the rate, correct? So I'm going to clear off a space here somewhere. I think I'm going to go back up here somewhere and give myself some room. I do apologize for writing on top of myself, but I am out of space. Uh-oh, this is going to take a while to erase. I'm sorry you have to waste time watching me erase things. Boop. But the eraser function for this is terrible. Okay, I'm probably going to drive Tom crazy when she sees this. All right, so here we go. Okay, so it says according to model, so I take the derivative of this, right? So I go back and look at this, and I'm going to go, aha! I've got function is t cubed minus 30t squared plus 298t minus 976 is my original. It's the rate at which they're being put in there. So I want to find the derivative, and I'm going to set the derivative equal to 0, correct? And so I'm going to go ahead and go minus 30t. Okay, so then I'm going to get 3t squared minus 60t plus 298 p prime of t. Now you're thinking, factors of 3 times 298 to give me negative 60. No, thank you. Good news is you have your calculator. We've just learned how to use our calculator to find zeros. We know it's got to be between 8 and 12, so all you have to make sure is your window is set between 0 and 12. Okay, so I'm going to go ahead and do this. I've got 3x up carried 2 minus 60x plus 298, bang. And then I'm going to make sure my window starts at, say, 7 and ends at, say, 13. Boom. I'm going to ask to graph it, draw it. Okay, so if 7's on my left side, 8, 9, it's just a little past 9 and just a little past 10, 11. Ooh, I didn't expect that. Okay. All right, so I'm going to hit G solve. Root. I'm going to ask my calculator to find the points while I'm waiting. Okay, so mine found a value at t equals 10.816 and 9.1835. There we go. Okay, then how do I figure out where the values are? Here we go. We want to know when the maximum would be for putting away things. We've got to check 8. We've got to check 12. We've got to check 9.2835. And we've got to check, got to check 10.816. I'm going to check them, okay, by putting the equation back, the original equation back in my calculator. I'm going to table it. So it gives me all the correct answers, and I'm just going to find the highest value. So according to my table, I got 0. Oh, where's my pen? There's my pen. 0, 5, 3, and 8-ish. Okay, so with that in mind, what's the winner? 12. And so at t equals 12 or midnight, these people are putting away their ballots at the fastest rate, the processing entries at the fastest rate. So that's how to do this type of problem. So, got questions? Hopefully I have answers. Please have at.